Good morning, friends. So today discuss about laws of motion chapter. Laws of motion. So this is the first year physics laws of motion chapter. So in this laws of motion, first I will discuss about impulse. What is the topic? Today topic is called impulse. Impulse. Okay, so what is the impulse? So what is meaning of the impulse? The impulse is generally indicated capital I or J. What is the symbol? I or J. So here their impulse capital I is equal to product, means multiplication of force into time duration. So this is I is equal F into T is called impulse. So that is here. What is the impulse? Impulse is equal to force into time duration. Force into time duration is called impulse. And what is the another definition? The second definition. The second definition of the impulse is equal to here. The second definition of impulse is equal to change in momentum. Change in momentum. So what is another definition? The change in momentum is equal to impulse. Is equal to impulse. Here, so how to change in momentum? There, change in momentum, impulse J is equal to delta P. I will prove the equation. So how to prove? So I or J is equal to F into T. What is the Newton second law? The Newton second law. We know that very well. The Newton second law. What is the Newton second law? F is equal to ma, where a is equal to acceleration. What is the a value here? A is equal to acceleration. So here I am taking, so can write the formula of the acceleration. First one, you can write the formula of the acceleration. We know that a means acceleration is equal to change in velocity. Change in velocity by time. Change in velocity by time. So that is v minus u by t. So I is equal to f into t. F is equal to ma into t, and m, what is the a value? A is equal to v minus u by t into t. So where t cancel, m into v minus u, that is mv minus mu. Here I is equal to mv means mass into velocity is called momentum, and mu also mass into velocity. This is momentum is final momentum pf, minus this momentum is called initial momentum. So I is equal p f minus pi. So that is I is equal delta p, where the delta p means change in momentum is equal to, change in momentum is equal to impulse. So here I will explain once again. So what is the impulse? The impulse, what is the symbol of the impulse? I or J. This is the indication of the impulse symbol. What is the formula? I is equal to F into T. The product of force and time. The product of force and time is called impulse. So the impulse is equal force into time duration. So what is the another second definition? Impulse is equal change in momentum. So that is J or I is equal to dP. So I is equal to Ft. I'll prove the equation. What is the proof? How to prove this equation? So by using Newton's second law, F is equal to ma, a is equal to acceleration. So we know that very well. What is the a? A is equal to change in velocity in the above equation. Here you can see it. A is equal to change in velocity by time, v minus u by t. So where I is equal to f into t, that is ma into t. A is equal, we know that very well in the upper equation. Substitute in this equation. So where t and t is a cancel, v minus u, there I is equal to mv minus mu. So mass into velocity is called momentum. So this is a final momentum pf, and mass also, it is also u is equal to initial velocity. So where v is equal to final velocity, u is equal to initial velocity. The object is moving particular velocities u and v velocity. So therefore finally we can get I is equal to delta p. So this is called as impulse. Next, impulse units and dimensional formula here. Okay, so the impulse, their formula will be completed. Okay, here now I am writing impulse. So first one, units. Okay, and next dimensional formula. So what is the units of the impulse? What is the dimensional formula impulse? So we know that units, so first I is equal to F into T. And what is the units of the force? Force is equal to Newton. And what is the units of the time? Second. So that is impulse unit Newton second. This is the SI units only. SI units. So what is the dimensional formula? I will write I is equal to F into T. Force dimensional formula M1 L1 T power minus 2. Time dimensional formula T power 1. So I is equal to M1 force L1 T minus 2 into T power 1. So I is equal to M1 L1, here T power minus 2 into T power minus 1. So by using in the mathematical equations, that is a power m into a power n is equal to a power m plus n. Similarly, T power minus 2 into T power minus 1 is equal to, plus 1 is equal to T power minus 2 plus 1. Here also plus 1. So that is T power minus 1. So what is the dimensional formula here? The dimensional formula, finally we can get I is equal to M1 L1 T power minus 1. This is a dimensional formula. And some key points, some important points. Okay, so what is the important points here? First point, some key points. So this is the key points. So what is the key points? So first point, key point. So always, what is the direction here? Another one. So it is a vector quantity. What is the third one? It is a vector quantity. The impulse is a, third one is a vector quantity, because the force is a vector. So therefore it is a vector quantity. And what is the key points? What is the important points? The first point, force, acceleration, change in velocity, change in momentum, and impulse always same direction. Always same direction. First point. What is the directions? Here, force, acceleration, and change in velocity, change in momentum, impulse always same direction. Second one, suppose their impulse force is variable. Force is variable. Force is a variable force. Force will be changes with respect to time. In this case, what is the impulse here? I is equal to integral p1 to p2 dp, or integral T1 to T2 F into dt, where is applicable? F is equal to variable forces. Variable force is given, impulsive forces variable is given. Now that time it is a using, this is a formula. And here next, third one, so graph. Okay, we know that very well, there graph. Okay, so here I am taking two, one is x-axis, another is y-axis. In the x-axis I am taking the time, y-axis I am taking the force. So there, draw the graph and force and time. It's give, this is a curve. Okay, the area bounded, this is area, this area bounded, it's give the impulse. Let's give the impulse. Area bounded, this is the area, complete area bounded, this is the T1 and T2. The area bounded is give the impulse. So this is a graph. Taking the graph, x-axis and y-axis. In the x-axis I am taking time, in the y-axis I am taking the force. Draw the graph force and time. So this is a graph. So this is a shadow. Okay, the shadow is indicating, this is the area, this is a area bounded by force and time graph, force and time graph with time axis. This is a T1 time, this is a T2 time. With the time axis is give impulse. Especially in the graphs, force and time is given, this is the area is bounded, this area bounded, it's give impulse. So this is complete about of a impulse. What is the fourth point of the impulse? The fourth point of the impulse may be positive, may be negative, may be zero impulses. Okay, so when their change in momentum is increases linearly, that is a positive impulse. Where change in momentum decreases with respect to time, that is a impulse is negative. Suppose the change in momentum, that is there is no change in momentum, constant remains constant, there is no change in momentum. So what is the impulse? Their impulse is a 0. So therefore impulse I is maybe positive, maybe negative, maybe 0. So this is about of a complete impulse. Next, applications. So what is the important of a applications? So is very important of the applications. We know that very well in the cricket, especially cricketers. Okay, a cricket players lower his hands while catching the cricket ball. This is a very good application. A cricket player lowers his hands while catching a cricket ball. So here generally what happen in the cricketer, so this is the one ball, here the ball is thrown particular velocity. Okay, so it is having some momentum, so the cricketer is having throw this ball. When this ball is inside or incident in your hands, what happened? These hands is lowered your arms. So in this case what happened? In this case here the longer time it is moving, the change in momentum is very less, their force will be very less. Okay, we know that I is equal to F into T. Their hands will be longer time, the force will be very less, so therefore their very less force is acting, there is no injured. Okay, so this is the first application. And what is the second application? Is very simple application. Suppose taking two floors, so this is a cement floor. So what is the floor here? This is cemented floor, okay, and this is heap of sand, heap of sand. Suppose here one person is there, this is a one person, okay. So this person falls from particular height, this person fall particular height. So it is on cement floor, is injured severely. So the total change in momentum is produced smaller. In this case, total change in momentum is produced smaller and smaller interval of a time. Okay, so this floor exert much larger force. So due to it, the person is injured more severely. All of you understanding? So let us take, I am taking the cement floor. One person is jumping particular height, small edge. Okay, so what is the change in momentum? The change in momentum is very small. Okay, the force is exerted on a cement floor is more. So this person is injured more severely. Suppose this same person is freely falling or jump in a heap of sand. Okay, so what happened? Their person is penetrate inside. That means in this one their time will be increases, force will be decreases. Time will be increases, force will be decreases. So therefore this person is very small hurt because their heap of sound, that means their person is penetrating inside of a sand. So this is one of the second application of. So next one, third application. What is the third application? China wares. Okay, China wares and glasswares. We know that very well in the packing, especially in the packing systems. Okay, the China wares and glasswares is wrapped in a paper. So in a Amazon and Flipkart, what happened? So this is the one glass. Suppose the glass is there, inside some papers is there, papers wrapping inside of the papers. What is the reason? It is a jerk. Okay, the vehicle is moving, so what happened? It is a jerk. So due to time will be increases, their time will be increases. So that is their braking will be reduced. So this is another application. And what is the fourth application? All vehicles. Suppose what is the vehicles? Scooters and cars and buses and trucks, etc. is provided shock absorbers. We know that very well, especially in the boys. Okay, we know that shock absorbers. Okay, the bike is having like this, and beneath of a seat the shock absorber is there. What happened in uneven road? This is the uneven road, not to equally road, in uneven road. So the impulsive force exerted by the road, the function of shock absorbers to increase the time. What happened in this one? Time will be increases. Okay, so the bike or car or bus, anyone is moving in uneven road. The road is not clear, the road is uneven. What happened? The shock absorbers is moving up down. When this shock absorbers is moving downward, it is very slowly, that is increase the time, automatically increase the time, the force will be reduced. This is also one of the good applications of the impulse. And next one, another one example, athletics. Okay, some athletics in the running races. Okay, here this is a running track. Okay, a running track. This athletics is moving is very fastly Okay, so after near to the target, what happened? It is not stopped suddenly. It is moving particular distance. It is moving particular. So this is a running track. Okay, for example, running track. So this is a target. Okay, here the person is moving is very fastly. At this one, it is not stopped. What happened? It is moving. It is moving is very slowly, finishing the track. This one, the time of stop increases. The time of stop increases and the force experienced by him decreases. These all are about a impulse and impulse applications.